Hello there, Mr. Sutton here, bringing you the Algebra 2 10.5 Part 1 homework solutions on graphing the other trigonometric functions. In this one, we are focusing on tangent and cotangent. For this one, we are graphing 2 tan of x. To start with, let's figure out the transformation going on. We just have a 2 outside, which gives us a vertical stretch. So my parent function for tangent, the table there, here are our values. We have negative pi over 2 through pi over 2. We have an asymptote, negative 1, 0, 1, and another asymptote. So let's figure out what the g function looks like now. For the x values, since we don't have anything going on inside the function, the x's are going to stay the same. Since we have this 2 outside the function, we're going to do 2 times the y values. So for the x's, we still have negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And for the y's, we have undefined, and then negative 2, 0, positive 2, and then undefined, or an asymptote. So graphing this out, I think if we go by pi over 4s, that should capture everything we need here. So we have a vertical asymptote at negative pi over 2. We have the point negative pi over 4, negative 2. We have 0, 0, pi over 4, comma 2, and the asymptote at x equals pi over 2. And now we just draw a curve following the asymptotes and going through those points. For this problem, we're trying to graph g of x equals cotan of 2x. The 2 inside here is telling us we have a horizontal shrink, since this is bigger than 1. For my parent table, here we go. We've got a 0 through pi, and then we've got 1, 0, and negative 1 for the points, and a couple of asymptotes in there. For the transformation for g of x, since we have the 2 inside the function, that means we're doing 1/2 times x. Since there's nothing other than a 1 outside the function, y values are going to stay the same. So for the x's, we've got 0, and pi over 2 times 1/2 is pi over 8. Pi over 2 times 1/2 is pi over 4. 3 pi over 4 becomes 3 pi over 8, and pi becomes pi over 2. And now for the y values, those are all staying the same, so we still have an asymptote at 0, and then 1, 0, negative 1, and another asymptote. So looks like based on the x values here, if I make my horizontal grid lines go by pi over 8s, that should get me what I need, and I can just go by 1s for the y values. So I have an asymptote at x equals 0 right here, and then we have pi over 8 comma 1, pi over 4 comma 0, 3 pi over 8 comma negative 1, and then another asymptote at pi over 2. Alright, so let's just follow those asymptotes and go through the points, and here is our cotan curve. On this problem, we're doing g of x equals 1/3 tan of 2 pi x. Let's start with figuring out the transformations happening. The 1/3 out here gives us a vertical shrink. The 2 pi inside, since that's bigger than 1, it's giving us a horizontal shrink as well. And now for the parent table, we have negative pi over 2 through pi over 2 with all of the asymptotes and points in there. And for the g function, since I have this 2 pi inside the function, for my x's I'm doing 1 over 2 pi times x, or x divided by 2 pi, either way. And then we have 1/3 times y for the y values because of that vertical shrink. So for the x's, we've got negative pi over 2 times 1 over 2 pi. The pi's are canceling, and we just have basically negative 1/2 times 1/2, which is negative 1/4. And now down here, negative pi over 4 is going to turn into a negative 1/8. If I multiply that by 1 over 2 pi, 0 is still going to be 0. Pi over 4 becomes 1/8, positive, and then pi over 2 is now going to be a positive 1 over 4. For the 1/3 times y's, undefined is still undefined. Negative 1 is now negative 1/3. 0 is 0. 1 is 1/3. And we've got this undefined still being undefined. Judging by my x values, I think if I go by 1/8 on the horizontal, that'll do it. For the y values, I'm thinking 1/3 probably makes sense given my scale here. So we've got negative 1/4, which is over here, negative 0.25, and that's an undefined value, so we have an asymptote right there. Then we have negative 1/8, negative 1/3, which is down here, 0, 0, 1/8, comma 1/3, and an asymptote at 1/4. And then here's my tangent curve through those. For this problem, we are graphing tan of 1/2 x. The 1/2 in there, since that's less than 1, gives me a horizontal stretch. For my tan table, here it is. We've seen the parent table a few times. And for the g function, we're doing 1/2 x in the function, so that means we're actually doing the reciprocal of that, 2 times x, for the actual rule that we're applying. There's nothing outside the function, so the y values are not going to change at all. So for 2 times x, we multiply each of these x values by 2. So negative pi over 2 is just going to become negative pi. Negative pi over 4 becomes negative pi over 2. 0 is 0. Pi over 4 is now pi over 2. And pi over 2 is now pi. For the y values, we just keep the originals. We're still undefined at negative pi over 2. Then we've got negative 1, 0, 1, and undefined. So judging by the x values, if I go by pi over 2's on my horizontal, that'll give me everything I need to show all these essential spots. And then I can just go by 1's on the y-axis. So I have my first asymptote at negative pi right here. I have the point negative pi over 2 comma negative 1. And then 0, 0, pi over 2 comma 1, and another asymptote at pi. And then let me just draw my tangent function following the asymptotes and going through these 3 points. On this problem, we're trying to graph 3 cotan 1/4 of x. For the transformations, we have a 3 out here giving us a vertical stretch since that's bigger than 1. And this 1/4 inside, since that's smaller than 1, this gives us a horizontal stretch as well. So stretching in both directions. For the parent table, here's our cotan table from 0 to pi. And for the g of x table, for the x values on this one, the 1/4 inside means we're doing 4 times x for the actual rule. And then we have 3 out here giving us 3 times y for the y values. So for the x's, we're just multiplying each of these by 4. So 0 is still 0, but pi over 4 is now just pi. Pi over 2 is going to be 2 pi. 3 pi over 4 is 3 pi, and you can probably follow the pattern here. 4 pi is next. For the y values, multiplying by 3, undefined is still undefined, and then we have 3, 0, negative 1, or negative 3 rather, and also undefined. It looks like I can go by pi's for my x values, which is kind of nice. For the y values, we can either go by 1's or 3's, won't really matter. I can fit 3's if I just go by 1's. So let's do our vertical asymptote at 0, and then we have pi comma 3, 2 pi comma 0, 3 pi comma negative 3, and 4 pi is our other vertical asymptote. And then let's just draw our cotan curve through those points and approaching those asymptotes.